Hello everybody, welcome into another lesson. So today we are going to talk about solving quadratic equations by completing the square. So this also may seem like a review from Algebra 1 where we talked about completing the square to solve quadratic equations. The difference is now for solutions we have the whole set of complex numbers instead of just real numbers. But if we recall, you have a quadratic equation of the standard form ax squared plus bx plus c equals 0. Now, completing the square only works if the coefficient on the x squared term is 1. If it's not 1, we have to make it 1, and we'll go through that when the time comes. But the idea is the coefficient on the x squared term is going to be 1. So you'd have x squared plus bx, but what you need to do is get rid of your constant term, the c, out of the left-hand side, move it over to the right-hand side. Because the next step is you're going to take your x squared plus bx, then what you do is you take half of your b coefficient, the coefficient on the x of the first term, and then you raise that to the second power and you add it to what you have over here. But what you do to one side, you have to do to the other. You'll also add it to the right-hand side. The idea of completing the square is on the left side, you'll get a binomial square, which will enable you to just solve basically by finding square roots. So this is more of the abstract concept. It looks hideous, but it's really not that bad when we get into some examples here. So let's do just that. Let's get into some examples. All right. So we have x squared plus 2x equals 9. Well, the good news is the constant terms are already on the right-hand side. It's not on the left, so that's going to make life easier. So you have x squared plus 2x plus 9. Okay, so to complete the square, of course you're going to keep your x squared plus your 2x, plus you'll take half of your coefficient on the x of the first term, which half of 2 is 1, raise that to the second power, and add it to the left side, but you also got to do that to the right hand side. You would get 9 plus 1 squared, which would end up giving you x squared plus 2x plus 1 would equal 9 plus 1. Then the left side ends up a perfect square trinomial, which would factor into x plus 1, that quantity squared, would be equal to 10 on the right-hand side. Now we just solve by finding square roots. So take the square root of both sides. But the plus and minus square root of the right-hand side. So that would give you x plus 1 equals plus and minus the square root of 10. As we know, the square root of 10 doesn't break down any further. So this would give you that x equals negative 1 plus and minus the square root of 10. And there's your solutions to this. X equals negative 1 plus and minus the square root of 10. Alright, so let's see. We have x squared minus 12x is equal to negative 28. So x squared minus 12x equals negative 28. So to complete the square, we'll take, of course, x squared minus 12x plus, now what's half of negative 12? That's negative 6. So plus that negative 6 raised to the second power is going to equal on the right-hand side negative 28 plus that negative 6 to the second power. So the left side would turn into x squared minus 12x plus 36 would equal negative 28 plus 36. So the left side is a perfect square trinomial, which will factor into a binomial square of the quantity of x minus 6 squared, which would equal 8 on the right-hand side. So now just take the square root of both sides. You'll have the square root of x minus 6, that quantity squared, equal to plus and minus the square root of 8. So the left side, you'll have x minus 6 would equal plus and minus. Okay, what's the square root of 8 breaks down into the square root of 4 times the square root of 2, which would be 2 times the square root of 2. So that means x is going to equal 6 plus and minus 2 times the square root of 2. So those are the two solutions to this equation. X equals 6 plus and minus 2 times the square root of 2. All right, we have x squared plus 20x plus 104 is equal to 0. All right, so x squared plus 20x plus 104 equals 0. Well, first thing you want to do is get rid of the constant term out of the left-hand side. So subtract 104 from both sides. You'll get x squared plus 20x equals negative 104. Now we're going to take x squared plus 20x plus, what is half of 20? That's 10. So plus 10, raise that to the second power, would equal negative 104 plus that 10 raised to the second power. So this will turn into x squared plus 20x plus 100 equals negative 104 plus 100. So the left side would turn into a binomial square of x plus 10, that quantity squared, would equal on the right-hand side negative 4. So now you just take the square root of both sides. So the square root of x plus 10, that quantity squared, would equal plus and minus the square root of negative 4. So then you have the left side would turn into x plus 10 would equal plus and minus, what's the square root of negative 4? That's 2i. So your solutions are going to be x equals negative 10 plus and minus 2i. So you have two imaginary solutions to this equation. X equals negative 10 plus and minus 2i. Alright, let's see. X squared plus 3x minus 1 equals 0. So we have x squared plus 3x minus 1 equals 0. Well, again, get rid of your constant term out of the left-hand side, so add 1 to both sides. You would get x squared plus 3x equals 1. Now you're going to take x squared plus 3x plus, now what is half of 3? Well, that's just 3 halves. You'll raise that to the second power. That would equal 1 plus 3 halves to the second power. So then you'll end up getting, of course, x squared plus 3x plus 9/4 is equal to 1 plus 9/4. So the left side will factor into a binomial square of x plus 3/2, that quantity squared. The right side would equal 13/4. So now just take the square root of both sides. We'll just take the square root now. That would give you x plus 3/2 would equal plus and minus the square root of 13 over the square root of 4. Well, that would give you the square root of 13 over 2. So that means x would equal negative 3/2 plus and minus the square root of 13 over 2. So those are your two solutions. X equals negative 3/2 plus and minus the square root of 13 over 2. All right. So we have u squared minus 4u is equal to 2u plus 35. All right. So u squared minus 4u equals 2u plus 35. Well, I'm going to say we get rid of the 2u term out of the right-hand side, but leave that 35 alone. So let's subtract 2u from both sides. This would turn into u squared minus 6u is equal to 35. So now let's complete the square. You'll take u squared minus 6u plus, what's half of negative 6? That'd be negative 3 raised to the second power would equal 35 plus that negative 3 raised to the second power, which would turn into u squared minus 6u plus 9 would equal 35 plus 9. So the left side would become a binomial square. That become u minus 3 raised to the second power would equal 44. So now take the square root of both sides. You would get u minus 3 equals plus and minus the square root of 44. Well, 44 breaks down into 4 and 11, right? So u minus 3 would equal plus and minus 2 times the square root of 11, which means u would equal 3 plus and minus 2 times the square root of 11. So those are your two solutions. U equals 3 plus and minus 2 times the square root of 11. All right, v squared minus 17v plus 200 is going to equal 13v minus 43. All right. So v squared minus 17v plus 200 equals 13v minus 43. So we want to leave the constant term on the right hand side and actually get rid of the 200 out of the left hand side. So let's start there. So let's just start by subtracting 200 from both sides to make the left side not have a constant term. So this will turn into v squared minus 17v would equal 13v minus 243. Now we want to get rid of the, let's get rid of the variable term out of the right-hand side, subtract v from both 13v from both sides, you would get v squared minus 30v is going to be equal to negative 243. All right, now we can start completing the square. So that'll be v squared minus 30v plus, now what is half of negative 30? That's negative 15. You would raise that to the second power, would equal negative 243 plus that negative 15 raised to the second power. So this would turn into v squared minus 30v plus 225 would equal negative 243 plus 225. So this is going to give you, on the left side, a binomial square of v minus 15. That quantity squared would be equal to the right side, which would be negative 18. So take the square root of both sides, you'll just get v minus 15 on the left would equal plus and minus the square root of negative 18. Obviously we have an I because of negative 1. Then you have 9 times 2, so that would end up being plus or minus 3i times the square root of 2, which means v would equal 15 plus and minus 3i times the square root of 2. So you have two imaginary solutions for this one. V equals 15 plus and minus 3i times the square root of 2. Alright, let's see. We have m squared plus 1.8m minus 1.5 is equal to 0. So m squared plus 1.8m minus 1.5 is equal to 0. Well, of course, let's get rid of the constant term out of the left-hand side, so add 1.5 to both sides. You would get m squared plus 1.8m would end up equaling 1.5. Now we can complete the square. You'll end up taking m squared plus 1.8m plus, now what is half of 1.8? That's 0.9. We'll raise that to the second power, would end up equaling 1.5 plus 0.9 raised to the second power. So this will turn into m squared plus 1.8m plus 0.81 is equal to 1.5 plus 0.81. So the left side becomes a binomial square. That'd be m plus 0.9 raised to the second power would end up equaling 2.31. So now just take the square root of both sides. You would get m plus 0.9 would equal plus and minus the square root of 2.31, which means m is going to equal negative 0.9 plus and minus the square root of 2.31. So that was a fun decimal solution. So m equals negative 0.9 plus and minus the square root of 2.31. Alright, last one for this lesson. So we have n squared minus 4/3 n minus 14/9 is equal to 0. So we had a decimal one, now they're going to give us a fraction one. So we have n squared minus 4/3 n minus 14/9 equals 0. Well, let's get rid of the constant term out of the left-hand side, so add 14/9 to both sides. You would end up getting n squared minus 4/3 n would equal positive 14/9. Now, let's start completing the square. You'll take your n squared minus 4/3 n plus you'll take half of negative 4/3, which would end up being negative 2/3, raised to the second power, which would end up being 14/9 plus that negative 2/3 raised to the second power, which would end up giving you on the left side n squared minus 4/3 n plus 4/9 would end up equaling 14/9 plus 4/9. So the left side becomes a binomial square. That would be n minus 2/3. That quantity raised to the second power would end up equaling the right side. 14 plus 4 over 9 is 18/9. That's just simply 2. Now take the square root of both sides. You would end up getting n minus 2/3 equals plus and minus the square root of 2, which means n would end up equaling 2/3 plus and minus the square root of 2. So there are your two solutions to this one. N equals 2/3 plus and minus the square root of 2. So this has been part 1 of completing the square. Next lesson we'll do part 2, where the coefficient on the quadratic term is not equal to 1. We'll deal with that. So I hope everyone has a great day. Take care.